Hello, you're welcome to class. My name is Jude Chukwudi, your anchor. Today is our day 8 of our Python class, and we're going to be focusing on Pandas as an important tool in data science analysis. So we'll be starting with the basics. So we're starting with the basics. So the basic commands. Starting with basic commands in Python, let's just use comments to run it. So Pandas is a software library for Python, and it provides tools for data manipulation and analysis. So we use it for data manipulation, we use them to do our analysis work. It is also important to ensure that the correct version of Pandas is installed for compatibility with your code. So when you don't have your correct version, you may be running into little challenges. So ensure that you have this, which we'll be doing in a short while. So the first thing is how to importing Pandas. How do we import Pandas? You'll use a markdown. So we import it by using this simple command: import Pandas as PD. So once you have done that, you run it, the memory will be imputed as such. So the next thing is to check your Pandas version. So checking your version. Write print, open bracket, then pd dot double underscore, then version, then double underscore, then you run. So this is version 1.5.3. that is what my system is showing. You can also check what your own system is saying. It may be the same or it may be different. So we're looking at the second aspect of our work, which is data frame creation. Remember I said earlier that list is just like a one dimension that has a block. It has a block, not like a bracket, but it's on its block bracket, and it just comes in just one line, known as series. But when we have it in more than one line, it becomes a data frame. So we can say that a data frame is a two-dimensional label data structure with column, potentially of different types. So this is what you need to know about data frame. So you can think of it like a spreadsheet or SQL table, a spreadsheet like what you see in Excel table, or SQL table where we have row and column. That is what we're talking about in data frame. It's not just one single horizontal or one single vertical dimensional platform. So if we want to see it now from a list, for instance, we can say my list as the name defining what we are doing is equal to, then open up a list, say 1 2 3 4 5. Now you say df, which is equal to my data frame now will now be pd, which is pandas dot data frame. Observe how data frame is written. That is how you always do it when you want to get a data frame. Then you say my list, put a comma, then columns. Always ensure that your spelling are correct. And you say column name. Can run it. So it's throwing up an error. Say type error from my list on the last line, the fourth line. Data frame my list. So data frame dot init. Got an say keyword range argument column. Now you look at the spelling again. So we have problem from the spelling. As I said, is always conscious of spelling. So I didn't spell this column well, so let me spell it again. Column. Okay, let's run it again and see. What is it saying this time? Columns and column. So let's remove this and run it again. Column. So I have to put an S here. M. Look at the spelling very well. First of all, remove this S. Column. Okay, let's run and see. Okay. Column. Let's now put S here. Put S here. Alright, you can see. Now it has been well arranged. You can see the struggle that is there. It must be in the right order and the right spelling and the right idea. If not, it will not give you the idea. So for me to see this column now, I can now say come down and just write df. I'll run and see. Now you can see that my data frame has come out. The first line being the index and the other one being the list. So you have list 1 2 3 and index 0 is 1. So this is a data frame that is showing you 2 dimensions. So let's also go and look at it from a dictionary perspective. So from a dictionary, remember I said dictionary is key value combination. Key value pair gives us a dictionary. So I can say my dict is equal to, pay attention, you see how dictionary is brought in with this bracing bracket. I'll go inside, we'll have A, and A had a semicolon, and I give us the list or the values in it. 1, 2, 3. For 1, put a comma. Now we'll have B, and B, put a colon to give us the value of B, and bring in our list and say B is 4, 5, and 6. So the next thing we'll do is say df is equals to pd, which is pandas dot data frame my dictionary. We'll run it to see if I can enter into memory without any problem. Now for me to now get the column, you come down and just write df. I'll run it again, and now we can go down now to see our key value. You can see that the index 0, 1, 2 is there. Therefore A will have the values of A, and for B will have the values of B. So these are your data frame. See how it has converted the series now into data frame. Now the next thing we are going to look at, data selection. So pandas provide different methods for data selection. That's what we should have in mind. So the first thing, around this and come down and you come and say how to select column, and say column selection. How do you do that? You can say df, and what is df? A, for instance, and we run it. So it is only selecting just the A from the work up. Remember, as you are working, it is the last work that you have done that Pandas sees as current. It will working with that current work. So you see that it has just cut off B, only selected A, and it gave us the value. The name is A, data type is integer 64. If you remember up the last class, we have integer, but it was integer 32. I have not even been able to know what differentiates 64 and 32, but they are all integers. Now we can select multiple column too. Okay, so in selecting multiple columns, for instance, what you need to do is just say df. Now when you are selecting multiple columns, pay attention to the brackets that are there. We are picking double bracket. If you fail to pick double bracket, you will not get your answer correct. And now you come inside and indicate you are picking A, then put the comma, very very important, then put the apostrophe and put B. You are selecting the two. Then when you run it, you see the value for A and B will come up. You can try selecting these two without putting double column, and you see the answer it will give you, but the answer I'm assuring you will not be correct answer. So you can also select row. You can select row 2, row selection. How do we do that? So use a different idea. Data frame, we use lock. I've spoken about lock before. And lock, yeah, you put the square bracket and you see you're taking index 0. So I finished teaching the class, but the volume is not there, so I need to see how to reteach it again so that you can be able to hear what I was saying. The challenge I had was there was no light, so the system ran off and I had to close. So when I continued, I didn't know that it was not giving recording volume. So I stopped at row selection using lock. So when you use lock, because I say that, for instance, selecting multiple column, you need to define the data frame, then you put double bracket because you are including two different including two different magnitude there, A and B. Had it been just A, you just use one bracket, but once it's more than one, you use double. If not, it will give you a wrong answer. So for the row selection, you write your df.log, then the row is the row 0, which is the first row. So once you have done that, it will only pick the work on this first row, and that is what we'll have here. We have A as 1 and B as 4. It will give you the name, which is row 0, and data type, which is integer. So for another way to do it again, you can use iLock. The other one was lock. Lock is talking about location. You can use iLock. This time you are using the row index, not the row label. So using the row index, iLock, using row 0 again, and when you run it, it will still give you the same answer. Then you can selecting specific value. You can pick specific value within a given row. So for here, we say data frame at 80, then it is on row 0 and you are picking A. So you are picking A. So when you run it, it will give you 1. It will give you 1 when you run it, because A has value of 1. Let's go up a bit again so you can see it. See that A has a value of 1. So that is what we need to pick out. And if you do the same thing for B, B has value for row, for this 0 index, it has value of 4. That is why you will get 4. Now for the same idea, we can use it for the row index too, to arrive at our various answer. Now we are looking at data manipulation. How can you manipulate your data? We start by adding a value column. We can add column to our present column. How do we do it? You write df, you put your square bracket, and you put your C as a text. So you now write pd.series. So you use this series. Remember, series is just picking up a list, one dimension series, whether horizontal or vertical. So now this is the value, and it is in three values, just like what we have here, so it can easily be acceptable. So when you have done that, the system will admit it. Then when you run your data frame, it will now show in this manner. So I can also come to my kernel and restart and clear all output. So you can clear all the output for me. Then I will come to this point. I can go to cell and say run all below. So let me come to say, maybe I will come down to class 8 where we started today. I will now stand on class 8 and I will go to cell. I will say run all above. So it will first of all run everything that we have done before previously, and if you get any error on the road, it will stop. Apart from that, it will run everything. After it has done that, it will stop at class 8. Then I can be running my class 8 one after the other, so that as I'm speaking, I'll be running it, you'll be seeing it, since my volume was not able to show. Okay, so we have talked about alloc. We're on data manipulation. Okay, on data manipulation, adding a column. So once I have done that, data frame C, then this PD is pandas, because you want to read the dot series. So pandas is attaching series, so it's adding this to the data frame. That is what he's saying. Remember, we said that Python have almost a human readable language, so you can be saying it and be seeing it. So we can also delete column. How do we delete a column? We use another code, df.drop. What are you dropping? You are dropping C, and axis is axis 1, and we have axis 0 and axis 1. Axis 0 is talking about your column. It's talking about your row, and axis 1 is talking about your column, and axis 0 is talking about row. So now that we are dealing with our column, we are working with axis 1. Had it been we are dealing with our rows, we'll be talking about axis 0. Now in place is equal to true means that we are now adding whatever we have done to memory. So if we have not put it to memory, it means that we can come later as we're working and still invoke something and we'll see that work. But once we are put in place true, you will not see it anywhere again in your work. So we are dropping C. So when we have done that, we run it, we have dropped C. So to be sure that we have dropped C, now let's put up this data frame and run it and see. So when we run data frame, we see that we are no more seeing C. It is just A and B. So that is how you can delete a column. Sometimes the column you are working, you don't need a particular column, there's no need to you. For instance, if you are working with something that has maybe receipt number or ID number, and you can't use ID number for calculation, so there's no point to continue using it. You drop it. This is how you can drop your ID number, and you continue using the values that can give you the required result. So now you can rename of your column. You can rename your column. So how do you rename your column? Now data frame dot rename. Now you are doing this on what? On column. It's a column work. So you open up a bracelet just like you are doing value, you are using dictionary. So what you want to replace is A. And what do you want to replace a with new a. This is what you want to replace a with. I say in place true. Remember I said in place. When you have done that, it has taken it to memory. So once it has been done, you cannot see a again in your work. So when you want to call up a work and you bring a, it will throw up error. So when you run this now, see that a that we used to see here has now turned to new a. That is how we continue to see it now. That's how we continue to see it now. So how to apply a function to a column. How to apply a function to a column. So given that we have data frame and that the name is new a. Now applying a function, now you start with dot apply, and this is lambda. Now you have to define your work. So lambda x, and x is x multiplied by 2. That is the function they are trying to define. So if we have this, we can now run it. By the time we run it, you see that our answer has come up, and it's just for new a. So what it's saying is that now the whatever is the value we have for new a, for instance we have 1, which is the value, which is the x. We are multiplying that x by 2. So if we have 1 multiplied by 2 will give us 2. And if we have 2 multiplied by 2 will give us 4. And if we have 3 multiplied by 2 will give us 6, and so forth and so on. So on and so forth. So this is name new a is there, and data type is integer. So the next thing again is to know how to do data cleaning. And we say that data cleaning is detecting and correcting or removing corrupt or inaccurate records from a data set. Remember that when we generate data, mostly maybe from the field, it will be frosted with a lot of error. Some of the error may be computational error, some may be value error, some may be imputing error. A lot of error can come up. You can have misspelling, misspecification of value. Some will be empty set, some will calibration will not be correct. All of them are pure problem for data analysis and data manipulation. So we need to know how we can be able to clean this and how to have a value we can use to do our analysis. So first of all, we should know how to check for null value. And null values are empty set, empty value. Now when you come to a set of value and there are places that does not have value, whether it is 0 or whether it is 1 or 2, just empty, regard to it as null value, and it cannot be able to be used for system analysis. It will throw up serious system problem, system challenge for us as data scientists. So we need to check it or remove it. So how do we do that? We do that using is null. This is what we use to do it. So how do we do it? We write df.isNull, and when we run it, it will show us if we have false or true. False means that the value is there, and true means that null, there is a null value there. That is why I say is true. So for here, for the values, they are all written. So you have false, 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 false. There's no true. That means we don't have any null value. But just imagine if this is millions of data, how can you be able to use it again to make sense out of it? So we need to add something to it. That is why we now sum it. So we dictate and sum our null values. So data frame df.isNull. Then you put up this open function, open bracket, then you put a dot and sum it. So when we now run it now, it will just sum all the null. So if there's any null value for new a, it will give up. But here there's no null value for a, and there's no null value. So the data does not have any null value. So that is what it has interpreted our work. The next thing is how to remove null value. Assuming the values we have that is null, we don't want them, we want to remove them so that our data will be clean or free from null. We use the command drop na, and in place true means that once it has been dropped, You cannot see it elsewhere again. Memory has removed it from our calculation. So when you run it, it has now run it. Assuming we want to know if there is any value, we can put up df and look at it again. It will give us those values, but those ones are not necessary for now. We will have our required value. We can also fill our null value. We can fill it instead of removing it. Remember that sometimes you can have 16 column and only one column may have null value. The rest 15 has important value that will give us insight. So rather than removing the whole row because of one column that doesn't have complete value, we can decide to do what? Fill it with value. So like here, we can fill it with our arithmetic mean. That means we can either fill it with our mean, with mode, or with median. When you are filling with mean, it means you are looking at the average. And when you are filling with mode, we are working mostly with text value. So for text value, for instance, we can see postal office or postal unit that can be able to deliver letter. We can say UPS, we can say DHL, we can say GIG, we can say Peace Mass Transit, for instance. And if they are all appearing, and maybe out of 100% of appearance, GIG is appearing 60-70 times, we can say that if they are missing value, most likely GIG will be the one that is missing. Then we can now use the value of GIG to fill every missing space. That is a way to fill up missing value. So we can now use that. Or if it is average, we can sum all the values we have and divide by the number, and we can have a value which is an average value, and we can use it to impute into those places that are empty. Then we have also done it. So how do you do it? You write df.fill ma, which is the missing value. In this case, we are filling it with 0 and in place true. So it has if there's a missing value, and we have this, and when we run it, it will automatically replace every missing value with what? 0, or whatever value we have set in place. So replacing of value, we can replace value. Maybe there is an improvement, or there's a decision to change some values, or you have observed that in your course of iteration there's a need to show up some things, change some values, and make some adjustment. This is a place, this is how you can do it. So you can replace your value by using df.replace. Now we are replacing 1 with 10, and in place is true. That is what he have told us here. So we are replacing 1 with 10, and in place is true. So when we run it, we see that we have replaced the value of new a that was 1, and it has now become 10. So that is how you can do what? Replace. So the next thing we need to know is grouping and aggregation. How do we group and how do we aggregate? So when we are grouping, we involve combining data based on certain criteria. It may be by attributes, maybe by character or behavior. So if it is by attribute, maybe you are looking at colors, we are looking at height, we are grouping human as against non-human, you are grouping male aside from female, you are people that have the same value orientation, or people that have the same income bracket, you can group them. So that is what we mean by grouping. Now by aggregation, we want to just bring everything under one line, one single row. It's just like summarizing what we have done. So if we have this value new a, which we have changed already up, and want to group them now, we can group them based on criteria. So we can do df.group by this new a and see what it will give us. So it will group, but this is a Pythonic language which is understandable by the computer, but it has done it. Seeing that we don't have much data, it's possible that when we have more data, it will become more understandable. So the next thing is aggregation, data aggregation. You remember we say in aggregation we are trying to turn result of a query into a single row. So now we want to aggregate this new A based on certain criteria. We want to see the minimum value. If you look at new A here, at least no minimum value is 2. We want to see maximum value, no is 10. We want to see the mean, that means 10 plus 2 plus 5, 15, divided by 3, 5. We want to see the sum, want to add. That's what we want to do here. So data frame aggregation, by the time we run this, all these things we've just said will appear. You see that this is this is this, and it is giving us a decimal point. Which letter we will teach you how to remove, or you want to increase decimal place. It is at your discretion to do that. We will use a particular function, a particular command, but that is not what we are doing now. So you can see that we are able to do aggregation. We get the minimum, everything about A. We have known that the minimum is 2, maximum is 10, the mean of that new A is 5, and the sum. So we are seeing the characteristics or the attribute of A from different perspectives under just one single column. So the next thing we want to do is to know how to merge, how to join and concatenate. These are 3 important terminologies that we need to know what they mean. Say that Pandas provide various ways to combine data frames, including merge and join. So the first thing we want to do is to concatenate. So we want to concatenate. We want to see what actually is concatenation. Concatenation talks about bringing together different values. You can see we have data frame, 2 data frames here, data frame 1 and data frame 2. So we say pd.data frame. Now what we have here is new A, and new A has number 1, 2 and 3, and we have B, and B has 4, 5 and 6. Then we have another data frame 2. It still have new A and data frame and B, and they have different values. Now we want to concatenate. Note that their numbers of in the series are the same. It's very important. If they are not the same, they may not be able to do this concatenation. And this is 3, this is 3, this is 3, this is 3. So now how do you concatenate? You say data frame, which is a new data frame altogether now, different from the 2, which comprises the 2 now, is pd.concat. So this is the command you use to bring it, and you are bringing data frame 1 and data frame 2 together. So when you run it, for instance, let's remove this first and run it and see. When you run it, it will run. So now you want to see the data frame. You now write df and run it again. Sorry, it will give us an error because this df is not recognized. Remember that Python is case sensitive. So we'll run it now. It will give us the concatenated work. So you see that this one has 1, 2, 3, 1, 2, 3. df2 have new A 7, 8, 9, 7, 8, 9. So it attached along the required column, and B has 4, 5, 6, 4, 5, 6, and data frame 2 has 10, 11, 12, 10, 11, 12. That is how concatenation is done. So the next one is merging. So in merging, you see we have data frame 1, we have new A, it has 1, 2, 3, and it has B 4, 5, 6. Data frame 2 also have new A 1, 2, 3, just like the first one, and they have C 7, 8, 9. So you have new A is common in the 2 with the same value, but we have C and B in the different data frame, so you can merge. So when you are merging now, you look for the value that is common. So you are merging pd.merge, that is the command. You are merging the data frame 1 and data frame 2, but it is merging based on certain criteria. So you're merging on new A because new A is common to the 2. So once you have done that and you run it, it will give you this data frame, having new A, it is not repeating itself because it's the same. Then you can now add B and C. So you see how merging is done, different from concatenation. Then let's see joining. So for joining, we have data frame 1, we have PD the data frame new A 1 2 3, we have B 4 5 6. Then for data frame 2, we have data frame just C 7 8 9. Now we want to join. So now say DF, which is a new data data frame we are trying to provide, is the same thing as df1 data frame 1 dot join data frame 2. So we are using this joiner to bring the two data frames together. So when we have done that and we run, it will give us this, the new A, B and C are together. You see, it's the same value, but it was brought through different ways or through different means. So we also work with date. We can work with date as far as Python is concerned, and pandas. So these dates have not been fixed, so you may likely not get any answer. So we just use the new convert to just show how you can actually join date, how date can be prosecuted using Python. So data frame does date, that date to be given is also pd dot to date time. So date and to date time, and this particular one is what you have copied here. So once you have done that, you convert it to that date time. When we start our work, we see it how it is done. So you can also do that for year, you can do that for month, you can do that for day. Then how to read a file in pandas. You want to bring in a file, use pd dot read file to bring file into a given environment. So you can call it data frame, you can call it data, as the case may be, but you have to define. This is a definition process. So but here we say data frame is equals to pd dot read csv. Remember, we have comma separated value, we have excel, we have text file, we have pdf, as the case may be. Even sql can also be brought in. So once you have read this pd.receive, this line is that particular, the name of the file as seen in a system. So once that name of file is read, then and you end it with .csv, it will now bring our work into the Python Jupyter notebook or Python environment, and we'll now start to have what we call a cursory look using our exploratory data analysis capability. Now you can also write to a CSV file. How do we do that? You write df to CSV, then this is the file name. You remove this file and copy the file name inside it. After that, you now have additional argument. You say index first, meaning that normally when you bring a work, just like what we did here, the system will bring out its own index here. But if you have a work that already have an index, it means you'll be having double index. So when you put index first, means that the one from your destination where you want to work now will be suppressed. So the index you are coming with will now be what is going to be superimposed here, because sometimes we can change this index from these numbers to other things. So if we have done that clean work and you now brought another 0 to it, it makes it look lousy. So we use this index first to make it to continue to look nice. So that is how you write your work. So for other files, for instance, you can also use this example like Excel. For Excel, you say Excel, just like df to csv, It will not be df to excel read, that is read it to excel, read the JSON and read to SQL, just like what we have done here. And we'll put the name of the file and the file will be run, and that is how you can be able to have justice to your work. So I will be stopping here. In the next class, I will take my time to teach on exploratory data analysis, after we should see if we can touch on the different errors in Python. As you can see, some of our work, throw ups error. Those errors are not supposed to frighten us. It's supposed to make us to understand how error is and what causes the error and how to go about solving error, and that will make you better. I also encourage you to increase your muscle memory by practice. It's not enough getting this note. When you don't practice, you will not become proficient, you will not be a champion at what you do. So I pray that knowledge will be with you. Do have a lovely day, and bye bye. God bless.
In today's world, data is the new gold. Data scientists unlock insights from raw information. They use statistical methods to analyze trends. Data analysts convert data into visual stories. By creating dashboards, they help organizations make informed decisions. Machine learning models can predict future outcomes. They identify patterns that aren't visible to the naked eye. Data cleaning ensures accuracy in analysis. Collaboration across departments enhances data insights. They utilize programming languages like Python and R for analysis. Cloud computing resources expand their capabilities. With big data, they tackle complex challenges across industries. Ethics in data science ensures responsible use of information. The future of data science looks bright with endless possibilities.